Today, I want to go over some key points of the wind power event for the 2025 National Science Olympiad competition. Okay, so the 2025 Science Olympiad Wind Power event has two parts, and the first part is a construction or device testing part, and then the second part is a written test. So for the construction part, or the build part, students will need to construct a blade assembly according to the rules and bring it to the tournament. Basically, the higher the voltage generated from the device, the better score you can have. And also that score is always proportionate based on who did the best and based on all the other scores based from the other teams in the region. So first, let's talk about wind turbine and wind energy a little bit. So a wind turbine is a device that converts the kinetic energy of wind into electrical energy. To convert any kind of kinetic energy, like from the wind, from a river, or from the ocean tide, into electricity, a turbine, which is a multiple-bladed part, needs to be pushed by this kinetic energy to rotate. Currently in the U.S., about 10 to 15% of all the energy comes from wind. In some of the Midwest states like Iowa, wind energy generates more than 50% of the total energy used. For this wind power event in Science Olympiad, we want our wind turbine to rotate as fast as possible to generate the highest voltage. And to do that, we need to put some thinking so that we can build a device as good as possible. Okay, so first, let's quickly review the 2025 wind power event rules. So here you can see the list of rules, and actually the only difference between the Division B and Division C is the maximum radial distance between the blade tip and the axis center. So for Division B, the radius is 14 centimeters, and for Division C, the maximum is 10 centimeters. And if you look at the rules, some other keywords are that you can't use any everything has to be non-metallic and non-magnetic, which means you shouldn't use metal nails or staplers in the device or etc. So the rules are basically the same as last year's, except for the blade assembly dimension. And finally, no design log is needed, which should save some time on the work. So how exactly do we make a good blade assembly device for the wind power event? Well, first I will go over some key factors that may affect the blade assembly device performance. Then I think I'll talk about a little bit of the building of the testing stand, and then finally I want to give a demonstration of my device testing for the Division B design. So when choosing your central disc selection, you're given two choices of either 8 centimeters or a 12 centimeter CD disc. So if you're using a 12 centimeter diameter disc, the possible maximum length of the blade would be 2 centimeters shorter than the one if you're using an 8 centimeter diameter disc, which means less cross-sectional area is being swept by the blades, and that means less available wind power is going through the assembly. And that is derived from the equation shown in the slide. The power available equals 1/2 times rho times the area swept times the velocity of the wind cubed. So for this question, I think it's a no-brainer that we should use the 8 centimeter diameter CD or DVD disc instead of the 12 centimeter one. Okay, so now we have our choice to make the device either rotate clockwise or counterclockwise. So which way is better, or does it really even matter? Well, first of all, in the industry, all commercial wind turbines rotate clockwise. And theoretically, there shouldn't be any performance difference between a wind turbine rotating clockwise and another wind turbine, which is exactly having a mirror design rotating counterclockwise. But for this event, a box fan will be used during the testing, which is actually different from the wind used in nature. So all household fans rotate clockwise, which somehow is in favor for the counterclockwise rotating blade assembly device. So I think there's apparently some explanation behind this from the perspective of aerodynamics, but I won't get into all of that. So my testing shows that counterclockwise spinning devices perform about 10% better than the clockwise spinning devices when using a box fan as wind source. I still remember when I was researching this, I was really puzzled and curious by this when I first found that because there shouldn't be any difference that the two identical devices would perform differently. So I did a lot of testing and research, and actually I found out that the reason was basically that there's a difference between the way it rotates from the wind box fan and the natural wind. So for this question, we have a winner, the counterclockwise rotation. So how many blades do we want to put on the device? Well, I don't think there's a perfect answer for this question for the reasons that the best number of blade assembly depends on the tip speed ratio, or the TSR, and the TSR is the ratio of the blade tip speed to the wind speed. So the device will be tested under low and high speed winds, and for different winds, different wind speeds, the best number of blades may be different. The performance of the actual box fan that will be used in the tournament is unknown. So therefore, different box fans may generate different wind speeds that will affect what is the best number of blades for that particular box fan. But however, my testing and calculations show that it may be a good idea to use 2 or 3 blades for Division B, and 4, 5, or even 6 blades for Division C. So for this wind power event, every team will face challenges to implement their design ideas while following the competition rules, like having to use a CD disc and that you can't modify a CD disc and that there is a blade length limitation. So a good resource to find a good airfoil shape is airfoiltools.com, which includes all of the NACA airfoil databases. So why do we want to make blades twist appropriately? Well, it's because we want to achieve a good angle of attack, or AOA, on the blade from hub to tip. You can watch some other YouTube videos to understand this topic and give your blade the appropriate twist. You can make blades from wood, plastic bottle, or a 3D printer. So no matter what you use, you want to try your best to make all of the blades identical. Unbalanced blade assembly won't perform well. When you mount blades on the CD, I recommend using Loctite superglue and letting it dry overnight before the first testing. So after I did all the research work, I completed the blade assembly devices for both Division B and Division C. So all the parts were designed in the CAD software and were printed in my home 3D printer. And also I will participate in the Division C competition and also volunteer to coach 2 Division B teams. And I hope it will be a lot of fun. Finally, you definitely want to test your device. To build a test stand, you will need to buy several items and do some, easy carpentry work. I think a high schooler should be able to do it, and I actually built the testing stand by myself. So, all the items except the motor holder can be easily found in Amazon and Home Depot. And actually, in the bottom right, that is me ready to cut wood using a circular saw. So the following video after this will show how my Division B device performs. And I hope everyone enjoyed this video and will learn something from this event about green energy. After all, I believe green energy, no doubt, is definitely the future. Thanks for watching this video and good luck to everyone in the competition.